Hello everyone. In this video, we continue our discussion about object-oriented programming. One of the most important topics in object-oriented programming is inheritance. Inheritance allows a new class to inherit properties and behaviors from an existing class. There are different ways to name these two classes, but something that is always important to remember is that in this case, we assume that we have an existing class, and then we want to define a new class based on this existing class. And usually the existing class is called superclass or parent class, and then the new class is known as the subclass or child class or derived class, right? But it's always important to remember this relationship that one is already defined and the other one is supposed to be created based off of the existing class. And inheritance is a very important topic because it promotes code reusability and establishes a relationship between classes. And therefore, this means that you can reuse, extend, or override the functionality of the superclass. So let's look at the syntax of how we can create this subclass. So remember, in this case, we can use the keyword class, and the name of the base class or superclass to define that. And in this case here, I put comment so that this means that we have some code here. You have usually a constructor, some methods. So this is what we use to define this parent class or base class. And then after that, now once you want to inherit from this class and define the subclass, we are going to use again the keyword class and the name of this subclass. And one thing that is important to remember is that we have to use these parentheses and put the name of the base class or parent class, right? So it's very much like when you define a class that we discussed before, except that in this case, we have to use these parentheses and provide the name of the base or parent class. And after that, now we have to have, again, constructor and methods that we want to use for this class. So let's go through the details of this and how we can do this through a very simple example. So in this case, we're going to first define a class called employee, right? So this refers to employees of a company. And this class has just a method which is called display info to display information about that employee. So let's look at how we can write that, right? So in this case, first we have our base class and we use the class keyword, the name of the class, which is employee. Then we have to provide the constructor to instantiate this class to create objects. In this case, we use def and these double underscores. Remember, these are special methods, which means that in this case, once you create objects, you have to provide these two attributes, name and employee ID. And self is what refers to the object being created. So in this case, we're saying that we have two attributes, the name of the object dot name and the name of object dot employee ID, and these are the values that we assigned. And then after that, for simplicity here, we are only using one method. And in this case, the method is display info, in which we want to just provide this information using formatted string or f string, where we have employee ID, and then the name of the employee, right? So that's kind of like our base class that we have here. But now we want to talk about our subclass. So the way that subclass works, as we said earlier, we choose the name, and then inside parentheses, we provide the base class, which is employee, right? And then use colon, and now we have to have our constructor and method and things of that nature. But let's focus right now on this constructor that we have. How does this work? Because something to keep in mind is that we do have a constructor for the original or the base class. And now we may also want to add more attributes for the subclass. So how can we do these at the same time? So as you can see here, the way that this works is that let's say we want to add one extra attribute here, which is department, and this tells us that which department this manager works for. And then the other first two attributes are identical to what we had before. So in order to define the constructor, it's easier to use the constructor from the original or the base class to assign those values to the corresponding attributes. And in order to do this, you can use the super function. So what this does, you use super.init and you provide name and employee ID. So why does this work? What this basically does is that this super is going to look at the constructor for the superclass or the base class, and it's going to initialize that using the information that we have, right? Because remember, name and employee ID do belong to the base class. And that's something that we can use using the super function. However, in this case, we have a new attribute that we didn't have before, and that's department. And in order to instantiate that one, we can just add that inside our constructor for the subclass. So let's see how this works. So when we define our subclass and especially the constructor, we have this init method, again with self as the first argument that refers to the object being created. And now we have three positional arguments. Then we are going to use this super.init with name and employee ID. So what this really says here is that we want to use the constructor for the original or the base class and provide this name and employee ID. So we don't have to repeat all these steps that we have done before. We can just put this one line and say that super.init. And in this way, we're going to use the constructor of the base class. However, we have to add one extra attribute here, which is this department. And in this case, we can use this self.department. So this really simplifies the process because we do not have to repeat these two lines that we had for the base class. So this is how we can use the constructor. But in this case, we also want to have a method called display info, but we want to override the display info of the base class because for the base class, we only have two pieces of information to print, the employee ID and name. But here we have actually three pieces of information, right? Name, employee ID, and department. So in this case, we defined a new method called display info. And even though it has the same name as the method for the base class, it is totally fine because Python understands that display info is a method that can be applied to the subclass and the base class. And the usage of these two methods is actually different, right? So if it applies to the manager class, which is the subclass, we want to print the employee ID for the manager, the name, and the department, right? So we have three things that we want to print. Whereas if it's for the base class, we actually have two things to print. And here there's no conflict or any issues. So just to show that how this works, let's just run this cell to define this base class and subclass. And now I want to create an instance of this manager class, right, which is the subclass. So we provide the name as expected, and then employee ID. So we assume that employee ID is 101, and then the department. And let's say the employee this manager here works for the IT department, right? And so if I create this object and put display.info method, you can see that we print these three pieces of information, and that's something that we expect, right? That's what exactly is supposed to happen if we use display info for an object of the manager class. But let's see if there's any issues if now we use the base class, which was the employee class. So in this case, remember, we only need two pieces of information, only name and employee ID. And in this case, if I use display info, we see that we only get information about employee ID and the name. And this is exactly what we expect, because if we use the base class, which is employee, we only have these two attributes, name and employee ID. So you can see through this example that this .display info works differently if we apply it to the base class or the subclass. And this is something that is very preferable, because in many cases, we want to make sure that we have different functionalities when working with different classes that they might have been inherited from some base classes. And you can see that now in this case, let's say for some reason we forget about the fact that employee class only has two attributes and provide this additional attribute, which is the department name. And if I run this, you can see that you get an error message, right? So the error message clearly says that we should have provided three positional arguments, but four were given, right? So this is because in this case, when we have this employee class, we have 1, 2, 3 positional arguments, but we provided 4, right? Because we also provided a department name, which was IT. And that's something that it doesn't work for the employee class, because we shouldn't provide that information. And that information should only be given when defining the manager class. Okay, so now let's make this a little bit more interesting, right? So let's say for the manager class, we want to add a new method, which is called assign task. In this case, this means that a manager can assign tasks to employees. And the way that we can do this is by adding a new method here, which is called assign task. And remember, self is something that we always have to include to know what object we are referring to. And the way that this works is that we provide two additional input arguments. One is employee and the other one is task. So this means that the manager assigns this task to this employee that we provide as inputs. And in this case, we just want to print that manager with this employee ID assigns this task to employee with this employee ID. So if you look at here, we are using this employee ID 2 times. But one is the employee ID of the manager, and the other one is the employee ID of the employee who is supposed to perform that task. So if we run this cell right now, and in order to make sure that we can do this task assignment, we need to have an instance of the manager class and also an instance of the employee class. So very similar to before, we do these object creations or instantiations. And then we say that manager instance dot assign task, right? That's something that we define here. And if you look at it, we need two input arguments. we need the employee information, and that's where we get the employee instance, and also the task. So the task here is just a string here, which says code a new feature, right? So let's say the manager wants to ask the employee to code a new feature, and if we run this, now it says that manager with this ID, and this makes sense because the ID of the manager is 101, assigns this task, which is provided here, to employee with this ID, right? And that's the exactly employee, the ID of this employee, right? So you can see that this is very powerful because now we have this original or the base class, and now we can subclass and add very useful attributes and methods that we need them. And we do this without writing everything from scratch, right? Because we are still relying on some parts of the base class. So just to recap these, right, just in terms of especially the way that we define constructors for the base class and the subclass. So we have this class and then again the name. For the base class, we don't use parentheses because this doesn't inherit from anything else. This is just its own class. And then we have some base attributes, right? So this can be more than one, but in general, these are the attributes provided for the base class. And the way you can do this is just by saying that self dot, the names of these attributes equal to these provided base attributes, right? So that's always what we can do for the base class. In our previous example, base attributes are name and employee ID. And then we create the subclass, right? And the subclass inherits from the base class. And in this case, for the constructor, we actually do have two types of attributes. The attributes that belong to the base class and new attributes that only belong to the subclass. For the first set, which is the attributes that belong to the base class, we can just use this super function, and dot init, you provide the base attributes. And if you're wondering here inside these super parentheses why we have this information, this is actually the right way, or I would say the formal way of using super, where you use the name of the subclass and then the self input argument dot init. But as you saw before, you can just leave these parentheses empty and it works. So that's one nice thing about Python, that is really smart in terms of understanding what we are referring to, because since we are inside this subclass, it understands like what we're trying to do. But if you want to be very kind of like formal and rigorous, you can always add the name of the subclass and the self input argument here to use the constructor of the base class. And then in the next line, that's when you use self dot sub attribute. And these are the attributes just for the subclass, where we do not have these for the original base class. Okay, so now let's do one more example to practice a little bit more. And let's say we want to have a class for calculating distances. So in this case, we have a two-dimensional space, meaning that for each data point, we have XY coordinates, right? That's something that we always work with, when we have like calculus one and in that area. And what we want to do is to calculate the distance of each point to the origin, and also the distance between two objects, right? So in this case, we can import the math module and we define our coordinate class. So that's class coordinate. So we do need a constructor. And in this case, to define or instantiate, I should say, an object, we need to know the XY coordinates, right? So that's why we have to provide these XY values. And we have self.x equals x, self.y equals y. And then we want to add a method to find the distance to the origin. So in this case, the formula is very simple, is a square root of x squared plus y squared, right? And therefore to implement this, we need to return the square root of the sum of x squared plus y squared. We can also define this other method that we have here, which is distance between two data points. So we have self here, which is the current coordinate that we are looking at. And then we need to have another object, which is the other coordinate. That's what we call it. And we have to find the difference between x coordinates, the difference between y coordinates. And after that, it's very much the formula that we had before, is the square root of this dx squared plus dy squared. That's how we find Euclidean norms. So let's see how this works. So in this case, in order to use this coordinate class to create objects, you need to provide the xy coordinates. So let's say one data point has this xy coordinate 3 and 4. So 3 is the x value, 4 is the y value, and then the other point is 1 and 2. So we created the 2 points here. And now you can use point 1 dot this method that we have here, distance to origin, and print the result, again, using the formatted string or f string. And you can see that something that we use here is this notation. And what this means is that we want to have two decimal places, right? Because when you find this distance to origin, you may have, many decimal points, and usually it's good to round these numbers. So this means that we want to have up to two decimal places in our result. And the same thing if we want to use the other method, which is called distance between, right? So you have to provide one object, which has these two xy coordinates, dot distance between, and then we have to provide the other coordinate. Like that's what it refers to here. And then this class tells us that the way we can do this is by subtracting the x and y values and finding the square root of the sum of these, the square of these differences. So in this case, if I run this, you see that we get the result. The first one makes sense because we have this data point with coordinates 3 and 4, and therefore the distance to origin is a square root of 9 plus 16, which is a square root of 25, which equals 5 as we get here. And then for the other one, we want to find the distance between these 2 points. And as we just discussed, you have to subtract the x coordinates, which we get 2, and then subtract the y coordinates, which again we get 2. And then the result would be a square root of 4 plus 4, which is a square root of 8. And that's what we get here. Just to make sure, we can do the math here, but this should work. And that's exactly what I was talking here about rounding these numbers, right? So if you find a square root of 8, you get 2.8284, right? So you get all these decimal places. And that's sometimes like really unnecessary. So what you can do is to say that you only want to see 2 decimal places. And you can see that in this case, we get 2.83. Okay, so now that we define this coordinate class, and this is actually right now our base class, right? Because if you look at it, this has not inherited from something else, right? If it did inherit from some other class, we should have like another base class here, right? But we do not have this right now, right? So this means that this is our base class. And let's say we want to do subclassing and create this new subclass, which is called enhanced coordinate. An enhanced coordinate just because it probably provides more functionality when working with these 2D data points. And you can see that this indeed inherits from the coordinate class that we defined before. So in this case, we want to slightly change the way that we instantiate this class. So we have the xy values for the two coordinates that we have, but we also want to add another attribute which is called label, right? So you want to, let's say, name these data points as A, B, C. So we provide that label. So you can see that for the attributes that they belong to the base class, we can just use super. We don't need to use anything inside these parentheses if we don't want to, and then use .init. And in the line after that, we can now say that, well, this self has another attribute, which is new, and that's this label, and do this assignment. And here the goal is to just add one more functionality, and that's finding the counterclockwise angle that that we have, right, uh, between that data point and the x-axis. So in order to do this, we can use one of the functions in math module, which is called this arctangent, and you have to provide the y and x coordinate. So you can search online for measuring the counterclockwise angle in radians, and you can see more information about this, arctangent. But because this is not a, trigonometry course, we, leave this here. But the goal is to kind of like, use this built-in method or function from math module to find this angle. And something else that also we want to do, because we want to find this angle in degrees. So we use this math.degrees to convert the result, which is in radians, to be provided in degrees. Okay, so now that we have this new method that we defined for our subclass, you can see that we can define an object using this enhanced coordinate. These are the XY coordinates, and this is the label that we just talked about. And even though for this enhanced coordinate that we have here, we never defined any method called distance to origin, but we can still use it because this inherits that method from the coordinate class. So this is what we are doing here. So here we're going to use this method called distance to origin. And even though, again, we didn't include this inside the definition of enhanced coordinate, it is already available because it's part of this coordinate class. That's the whole idea behind subclassing. And also, we can apply this new method, which is angle with x-axis. In this case, the result is kind of obvious because if you have this, point at location 2 and 2, that's the 45-degree line, right? Is on the 45-degree line, which means that the angle is 45 degrees. But we want to, make sure that we get the correct result. So if we run this, you can see that for the first result, which is distance to origin, we get a square root of 4 plus 4, which is a square root of 8. And we just check this, that should be 2.83. Again, we get this result because we have also 2 decimal points. And you can see that now this arctangent works too. And we get the degree, which is 45 degrees as expected. So the idea behind this example was to show you that even though we don't have distance to origin method for this enhanced coordinate, we can still use it because it is part of the coordinate class, which is the base class. So that now that we know about inheritance, we can also write more powerful classes in Python. That's something that we really need them when we want to work with objects in different contexts. So we had this idea before about these two underscores and using def init for instantiating objects from blueprints or designs provided in classes. And in fact, these are special methods because of these two underscores that we have. But one thing that is important to know is that this is not the only special method that we have, and actually we have a bunch of these. For example, one of them is this underscore underscore str, right? Which, as you know, stands for a string. So what this does is that it provides a human readable string representation of the object and returns a string. So what does this mean? So let's create a class. And in this case, we define a very simple class to just show the idea behind using this str. So in this case, we just assign one value to this attribute, which is called value. And now we define this special method str. And what this does, right, this is a function. It returns this string, which is a formatted string or f string, which says my class instance with value, and then you provide the value here. So this means that now that we create this object and we use print object, you actually get this information, meaning that once you call print function on this object, it's gonna look for this str, and if it finds it, it's gonna return this string that we have here. So it's kind of like the similar idea to class constructors, which means that when we call the class, automatically we are going to run the init method that we have. So that's the same idea here. When you use print, we're going to see if there is this str available, and we're going to print that. And also the other nice thing is that if you just use str, which is a function in Python, and then the name of that object, you again get that a string that we have printed out. The other useful thing that we can do with these special methods is to define what equality means. Because remember, right, as you can see here, we define a class and we have this attribute with the name value. So if I just create one class with value 2 and another class with value 2, these are indeed two different objects, right? Because one time we created one of them and the other time we created a new object. And although they have the same value for this attribute, but they are not the same. They're two different objects. So you can see that if I use this equality sign here, which, to make sure that whether the two objects are equal or not, you can see that we get false, which is not really useful because they do really have the same values, even though there are two different objects. So how can we get around this problem? And that's using this special method, which is underscore underscore EQ, right? And in this case, we have two inputs, the self, which refers to the object being created, and then other, which refers to another object. You do want to make sure that the other object belongs to the same class, because that's something obviously we want to have when we check equality. But then we're going to see whether the value attribute for the self is the same as the value for this other that we have here. And we're going to return the result of this comparison, right? So if these two are equal, then we get true. Otherwise, we are going to get false. So you can see that here, if I run this, because we did add this special method, now if we compare whether to see object 1 is equal to object 2, we get true. And that's something that, is possibly desirable in this scenario because they do have the same value. The last thing that we're going to talk about here, which is another important topic, especially in the context of data science, is what if we want to have methods with variable length input arguments, right? So in some cases, you want to give the option to the user to maybe provide multiple inputs The number of inputs really depends on how like the user wants to customize the method or the level of information that the user wants to provide. In order to do this, you can use these star args and star kw args. So I'm gonna tell or talk about very briefly about like what these things stand for, but these are very useful tools to provide these variable length input arguments. So args stands for arguments, and it allows a method, as we said, to accept an arbitrary number of positional arguments. So this is something very important to remember because that's what differentiates args with KW args. So in args, we want to provide an arbitrary number of positional arguments. And the way it works is that these arguments that are passed as args are collected into a tuple within that method. So let's create a very, very simple class. In this case, we do not even include the constructor because the idea is to show you how these args work. So we are going to define this method called print args. This is just a method. We use self, like always we do, and then we add these args. So what this means is that now the user can provide different positional arguments, and the number of arguments is arbitrary. But since these are provided in a tuple, now you can use a for loop to iterate over the elements that are provided. And in this case, we just want to print them to show you like, yes, they are actually passed along this method. So you can see that we create this object, which is instantiated from the example class. And then we use this method called print args. And in this case, we provide 1 and 2 and 3. So as you expect, now this means that we have a tuple here, which contains 1, 2, and 3. And now we go through each element and print that. But what is really nice here, that we can actually have an arbitrary number of inputs. So I can have only 1. So you can see that we print that. We can have 2. We can have 5. And so in this case, we can provide an arbitrary number of inputs. So let's put that back to 3, and you can see that that's how these args work. But how about that KW args? So that stands for keyword arguments. And this allows to accept an arbitrary number of keyword arguments. So this is the difference. The previous case, we set an arbitrary number of positional arguments. In this case, we have keyword arguments. And what does this mean? This means that actually we have key value pairs, like exactly when we talk about dictionaries in Python, which is a very important data structure, we have these key value pairs. So in this case, we create, again, a class called example, and we define a new method called print keyword arguments. And you can see that here you have to use 2 stars and then key. This name is basically like arbitrary, but again, it's a good practice to use KW args to know what we are doing. And because this is a dictionary, remember from the lecture on Python data structures, dictionaries, they have this method called .items. And this will give you a list of key value pairs that we have, which means that now we can write a for loop to iterate over them. And you can see that in this case, we are giving these names, or I would say keys and values, right? So name is the key, John is the value, similar here, age is the key, and 25 is the value. And if we add all this information here, you can see that we're gonna print each key value pair. But again, the nice thing here is that we can, for example, remove the city information. And if I run this, so now we have only name and age. But I can also put that information back, and you can see that now we have these 3 key value pairs. So that's something that you need to decide whether you want to provide positional arguments, meaning that you need to remember later on what is, this one, what does this one refer to? What does this two refer to, right? So this might refer to different attributes. But if you have multiple attributes, it's just much better to actually name them and provide this key value pairs. So let's go through quickly the homework assignments that we have. So in the first case, you want to modify that enhanced coordinate class that we have. So that's something that we define in the lecture. And add a new method called inQuadrant that determines whether a point that is represented by its xy coordinates is located in a specific quadrant or not, right? So we know that in a Cartesian plane, we have 4 quadrants, 1, 2, 3, 4. And in this case, we want to add this inQuadrant method and provide the quadrant number. So in this case, for example, 1 or 2, and we should get true or false, meaning that does this data point that we have belong to quadrant 1 or not? So, in this case, if you use all these quadrants 1, 2, 3, 4, so 1 should be true and the rest of them should be false. So this should be just a minor modification of the enhanced coordinate by just adding this method. The other thing that we want to do here for problem 2 is that to define this class called math operations, you want to define a method called perform operations. And in this case, we want to use these star args that we just talked about to be able to provide variable length input arguments. And what you need to do is to print 3 things. Print the sum of all the numbers that are passed as arguments, because remember, these arguments may not be numbers, they can be also strings, right? So we want to sum all the numbers, product of all the numbers, and concatenation of all the strings, right? So you can see here we have an example. Like if I provide a arbitrary, set of, numbers and strings, I want to be able to get the sum of these numbers, 2 pi 5 4 2, their multiplication, and also the concatenation of these two strings that we have. So this is another example to practice defining classes and using these star args. The next case or next problem, we want to define a class called rectangle. And in this case, you want to have 2 attributes. So in this case, you need to define a constructor and initialize these 2 attributes given the provided values. Add 2 methods, one to find the area, one to find the perimeter. But it's also here important to define a method, which is actually a special method called EQ, to compare 2 rectangle instances, right? So in this case, we want to see whether 2 rectangles are equal or not, and this means that their widths and heights should be the same, right? So you can see that here we have defined these objects, and we want to see, whether this rectangle 1 is equal to rectangle 2 or not. And remember, in order to do this, you actually need to define this special method so that Python knows how to compare the 2 objects.